Hey all! In today's video, we will be discussing Ncert solutions of the chapter Electrochemistry. So let's get started. The first question for the day is question number 1, and the question says, arrange the following metals in the order in which they displace each other from the solution of their salts. And then we have aluminum, copper, iron, magnesium and zinc. So in this question, we are supposed to arrange these metals in which they displace each other from the solutions of their salts. So we can answer this question on the basis of our knowledge of electrochemical series. So what is this electrochemical series? This is the table representing the electrochemical series. From this table itself, we can say that electrochemical series is the arrangement of various elements in the increasing order of their standard electrode potential. We can also say that this electrochemical series is giving us the activity series. That is, the most active metal occupy the top layer or the topmost position. From this we can see that magnesium is having the highest standard electrode potential. So we can say that the element magnesium is capable of displacing the metal ions from the salt solution. So in the same way, after magnesium, next comes aluminum. So that is having the next highest standard electrode potential, followed by zinc, and then we have iron and then the copper. So from this electrochemical series, we can say that magnesium will displace faster, followed by aluminum and then zinc and then iron and then copper. So this is the answer for the first question. Question number 2 says, given the standard electrode potentials, and then we have standard electrode potential for potassium, silver, mercury, magnesium and chromium. Now the question is, arrange these metals in the increasing order of their reducing power. This is the electrode potential of these metals. We know that greater the positive value, greater will be its reduction potential. So on the basis of that, I have written the increasing order of the reduction potential. Here we have silver having 0.80, that is the greater positive value. So silver will be having the highest reduction potential, followed by mercury, that is 0.79, and then we have chromium 0.74, and then we have magnesium, that is negative 2.37, and then we have potassium at the last. So this is the order of the reduction potential. Now we need to know what is the relationship between their reduction potential and their reducing power. Higher the reduction potential, lower will be the reducing power. So the order of their reducing power can be written just the opposite of this reduction potential. So we can write silver having the least, then we have mercury, followed by chromium, magnesium and potassium. So this is the order of their reducing power. All we have to know is, higher the reduction potential, lower will be the reducing power. So on the basis of that, we can say the reducing power is as follows. Question number 3 says, depict the galvanic cell in which the reaction, and then we have the reaction wherein zinc is reacting with silver, and then we are getting Zn2 plus and silver metal takes place. We have to answer the 3 questions. First question is, which of the electrode is negatively charged? Second question is, the carriers of the current in the cell. And the third question is to find the individual reaction at each electrode. In order to solve this question, let us first try to write down the cell representation. So, in the question we are given the equation as Zn, that is in the solid state, reacting with silver ion in the aqueous state to give us Zn2 plus in the aqueous state, and then we have silver metal in the solid state. So this is the given chemical reaction. From this, let us identify which among these two metals is undergoing oxidation and which is undergoing reduction. Now we know that zinc metal is undergoing oxidation because the oxidation changes from 0 to 2 here. So we can say zinc is the metal which is undergoing oxidation. So I am writing here as oxidation. Now we have silver which is undergoing reduction. So we can say here the oxidation state changes from 2 to 0. So silver is undergoing reduction. Once we know this, let us write the cell representation. How do we write the cell representation? To write the cell representation, we know on the left hand side we have the anode, and on the anode we have oxidation reaction taking place. And then we have the bridge, and then on the right hand side we have the cathode, and reduction reaction takes place here. From this equation, we already know that zinc is undergoing oxidation. So at the anode we'll write Zn bar, Zn2 plus, because zinc is undergoing oxidation. Then we put this bridge, and then at the cathode we have reduction, that is of silver. So we write it as Ag plus bar Ag. Now let us put the notations as here it is solid, here it is aqueous, again aqueous, and then this is solid. So this is the cell representation for this chemical reaction. Now the first question is to identify the electrode which is negatively charged. We already know that the anode is negatively charged, and here we have zinc metal at the anode. So we can say zinc electrode is negatively charged. So this is the answer for the first question. Now let us move ahead with the next question. The next question is to identify the carriers of current in the cell. We can say that inside the cell the current will flow through the ions, and outside the cell the current will flow with the help of electrons, and that is from silver metal to the zinc. And this will be the current flow, and the electron flow will be from Zn2 plus to Ag plus. This will be the electron flow. The current flow is happening from the cathode to the anode, and then the electron flow is happening from the anode to the cathode. From this we can say that the current flow will happen from the silver electrode to the zinc electrode. So this is the current flow. Now let us see what is the third question. It is to write down the individual reaction that is happening at each of these electrodes. So we know that at anode oxidation reaction is taking place. So we can write that as zinc metal at its solid state is giving us zinc ions plus 2 electrons. So this is the oxidation reaction. And at the cathode we know that the reduction reaction is happening for the silver ion. So we can write that as silver ion plus 1 electron is giving us silver metal. So this is the reduction reaction. I hope the answers for this question is clear.